Okay, the first problem that I want to do is the... Oops, sorry. Let me put it here. The first problem that I want to do is the following. Find two positive numbers. So, this is one of your homework problems. So, find two positive numbers whose product is 100, whose product is 100, and whose sum is a minimum, and whose sum is a minimum. Okay, so that's the question. Find two numbers whose product is 100 and whose sum is a minimum. So maybe the question is not clear the way it is stated. Think about numbers whose product is 100. So for example, if I take the number 2 and 50, right? The product is 100, and what's the sum? 52. I can also take the number 10 and 10. The product is 100, and the sum is 20. So what the question is asking, you can look at pairs of positive numbers. Pairs of positive numbers whose product is always 100. So there are many pairs, right? How many pairs are there whose product is 100? Can you answer that? How many pairs of positive numbers are there whose product is 100? I think each one of you can always, if I start from this side, if I ask each one of you to come up with a pair, I think each one of you can come up with a different pair. Okay? And in fact, there are infinitely many pairs whose product is exactly 100, right? One pair would be 1 times 100. One pair would be, like I said, 2 and a 50. How about half? If I pick one of the numbers to be half, what should I pick the other number? 200, right? So you can see I can pick one of the numbers to be 1/3, the other one to be. So there are infinitely many pairs. I want to find the pair for which the sum is minimum. Am I making sense? Look at all the pairs whose product is 100, and out of those pairs, pick the pair for which the sum is the minimum of all the sums. Am I making sense? So I have the product of 1 and 100. What's the sum? Sum is 1 and 1. Yeah, I have 1/2 and 200. What's the sum? 200.5. So look at all these sums. I want to find the minimum one. Am I making sense? So that's what the question is asking. So again, in all these questions in this section, you need to optimize certain quantity, okay? And those quantities will depend on some variables. So you have to understand what you're trying to maximize and what variables do they depend on. So what am I trying to maximize here? So first of all, we have to find two positive numbers whose product is 100 and the sum is as small as possible. And so let's label those numbers. So let's call one of them x, the other one to be y. So let's let x comma y be positive numbers such that x times y is equal to 100. Okay? So then what are we trying to do? We are trying to optimize certain quantity. What quantity are we trying to optimize here? In fact, are we trying to maximize or minimize? What are we trying to minimize here? Yeah, we are trying to minimize x plus, let's call that a name. Give that a name. Let's use s for sum. So we're trying to minimize the sum of x plus y subject to what constraint equation? Well, we need, what's the constraint here? We need the product to be 100, right? So the constraint equation is x times y must be 100. So we want to minimize x plus y subject to the constraint that x times y is 100. Is everybody okay? Is everybody okay? Now, if you look at x times y, okay, this equation, do you know what's the graph of that equation? Does anyone know the graph of that equation? I mean, just roughly, how does it look like? Do you know the graph of x times y equals to 1? When x and y are both positive. Yeah. It's like a half of a hyperbola, right? So this is how it's going to look like. It looks like this. So this is going to infinity here. So this is how the graph of here, see, y is equal to then what? Y is equal to 100 over x, right? Do you know the graph of 1 over x? If you know the graph of 1 over x, this is just stretching it, the graph of 1 over x, right? So the graph of this equation, xy equals to 100, looks like this. So x and y, so there are infinitely many pairs xy for which the product is 100. And we want to find the pair on this curve for which the sum is as small as possible. Okay? Now, what is our strategy here? Well, first of all, we don't know how to deal with functions of two variables. The quantity sum, this quantity s, depends on two variables x and y. And because we cannot deal with two of them, we want to reduce to one variable. And how do we do it? Well, we can use the constraint equation. From the constraint equation, I can solve for y in terms of x and put that in the function. So if I do that, what do I get for s? Well, we would be getting s, which is x plus y, would be x plus 100 over x, right? So that's our. So we have expressed the function that we are trying to minimize in terms of x. So now I can say that I am trying to minimize what? I can say that we are trying to minimize the function x plus 100 over x given or with subject to the constraint equation y equals to I have already written that down, so let me maybe not write that again. It's writing too many times. You know what's the constraint equation by now. Once I have this function, I'm trying to find the minimum value of this function now. But if I want to find the minimum value of a function, I need to know on what domain. Because depending on what domain, the minimum value might be different. So I have to specify on what domain am I trying to find the minimum value on. Am I making sense? So what's the minimum value of this function between 1 and 2? That's different from saying what's the minimum value of this function between 4 and 5, right? So depending on the domain. So I need to know exactly what's the domain. So reading from the question, what are the possible values of x? So can x be negative? Well, we are talking about two positive numbers. So the question already says they are positive. So x couldn't be negative or 0. So we can assume that x is what? X is larger than 0. Now my question to you is, can x be any positive number? Can x be any positive number? Well, sure. X could be any positive number, because whatever x you pick, like a billion or a trillion, okay, whatever x you pick, if you pick y from this equation, the product of x and y would be 100, right? Am I making sense? If I pick x to be whatever, and then I pick y according to this equation, then x times y will be 100. So for example, if I pick x to be, say, if I pick x to be half, right? What would be y? 200. If I pick x to be 200, then y would be half, right? So you pick x to be whatever you want, then y could be according to this equation. Okay, so my point is, I can pick x to be whatever I want. 0.1, 0.001, 1 million, 1 trillion. I can pick y accordingly so that the product is still 100. So there is no upper bound for x. X could be any positive number. You realize that? Everybody's okay with that? All right, so now I need to find, then, now it's just a calculus problem, right? The difficulty of this problem is to come to this point. Once you have arrived at this point, then it's just calculus. You just find the maximum minimum values. And we know how to do that from section 3.3. So now the question is, how do I find the minimum value of this function? Well, how do we find it? Well, take the derivative, look at the critical points, and so on, right? So let's look at s prime of x. That's going to be what? 1. What's the derivative of 100 divided by x? Yeah, notice that 100 divided by x is the same as 100 x to the negative 1, right? So the derivative would be minus 100 x to the negative 2, right? Which is the same as what? Which is the same as 1 minus 100 over x squared, right? You guys are okay with that? Okay, now I want to find the critical points. So solve s prime of x equals to 0, or s prime of x does not exist. S prime of x doesn't exist when x is 0, but I don't care about that. It's not in the domain. Okay? And then look at s prime of x equals to 0. That would mean that 1 minus 100 over x squared is equal to 0. And what does it tell you about x? It tells us that 100 over x squared would be 1. It tells us that x squared would be 100. And then it tells us that x is what? I wouldn't take minus 10 because remember, x is a positive number, right? So the only value, only critical point I get is x equals to 10. Everybody's okay? We are not taking negative 10 because remember, we are saying we are looking at two positive numbers, x and y. So x is positive. So then I have the critical point that I want. Now I have to find the minimum value of the function s. So how do I know where the minimum is? Well, the minimum is at 10, but I can justify why the minimum occurs at 10 by the following. I can sketch the real number line from actually I have to look at from 0 to infinity only because the domain is from 0 to infinity, and at 0 I have a hole because 0 is not in the domain. The only critical point I obtained is 10. I need to verify what is the sign of the derivative function on the left and right side of 10. So let's look at the derivative function. If you look at the derivative function, what can you say about the sign? When x is less than 10, right? When x is less than 10, like 1, what's the sign? Negative. When x is bigger than 10, then x squared would be bigger than 100, which would mean this quantity would be less than 1. So you're subtracting, you're going to get positive. So when x is larger than 10, this quantity is positive, right? For example, if x is if x is 20, right? Then what is 10 divided by 20 squared? Sorry, 100 over 20 squared. 20 squared is 400, right? So this would be 1/4, which would be 1 minus that would be positive. So my point is, I know exactly where the derivative is negative and positive, and therefore the function s is decreasing here, increasing here, and is it clear that the minimum value is at 10? So what's the minimum value? The minimum value is s of 10. That's where the minimum occurs. And if x is 10, then what is y? If x is 10, what is y? Remember, x times y needs to be what? 100? So y would be what? 10. So that's my answer, that the sum of x and y would be minimum when x is 10 and y is 10. So remember, we had all those choices. I can pick x to be half, y to be 200. I can pick x to be 2, y to be 50. I can pick x to be 10, y to be 10 as well. And we are saying I get the minimum sum of x and y when x and y are both equal to 10. Is that okay? Is everybody okay with that? Okay. All right. Any questions on that problem? Is everybody okay with that? Okay. Let's look at another problem. So the problem that I just did, that corresponds to problem number 3 in your homework. And now I will be looking at problem number 14 in your homework. In this question, you are given the following: a box with a square base, a box with a square base and open top, must have a volume, of 32,000 cc. And the question is, find the dimensions of the box that minimize the amount of material, used. Okay, again, word problems are always, you have to make sure you read it a couple of times to understand what the problem is asking for. In all these problems in optimization section 3.7, remember, you are always trying to optimize, either maximize or minimize a quantity, okay, and given some constraints, okay, given some constraints. And so you always need to write down what quantity you're trying to maximize or minimize and what variables do they depend on. Okay. So first of all, in order to understand this problem, this type of problems, it's always a good idea to draw some diagrams to understand what's going on. So in this case, we are talking about a box. So let's draw a box. Sorry. Okay. So okay, I have a box here, and remember the top of the box is open, and let's say, remember the base is what? Base is square, which means that the length and width are the same, right? So if I label the length of this side by x, what would be the length of the other side of the base? X. And let's label the height by h. Okay? So again, what are we asking here? We are asking to minimize the amount of material that is needed to build the box, right? Okay, if I'm trying to minimize the material that is needed to make the box, what am I trying to minimize? Think about this classroom, right? You're trying to minimize the amount of material that is needed to make the walls and the floor. What are we trying to minimize? Area? What area? You're trying to minimize the surface area, right? So if you can minimize this total surface area, you are going to need, you're going to be minimizing the material that is needed, which means you're going to minimize the cost as well to build that box. Am I making sense? So it's like so suppose you have a manufacturing company that makes boxes, like cardboard boxes, right? And you have certain businesses, they are ordering boxes, and they say, hey, I want boxes with volume equal to 32,000 cc. Because they might be needing those boxes to fill them in with something that's with volume that much. Okay. And when you get the order, as a manufacturer, what do you want to do? Well, you want to, if that's the only restriction, that the volume needs to be that, you want to minimize your cost. And how would you minimize your cost? Well, you want to pick the dimensions in such a way so that the total surface area is as small as possible, right? Is that making sense? So think about what is the volume here. What's the volume of a box? What's the volume of a box? Yeah, so in this case it's x times h, which would be x squared h, right? And what is our requirement? The requirement is that this volume is 32,000 centimeter cube, right? So that's the now what are the possible values of x and h. What are the possible values of x and h? Can someone give me a value of x and a value of h for which the volume is 32,000? Can you give me a value of x and a value of h so that the volume is 32,000? I mean, what is it possible? What possible dimensions can the manufacturer pick? Yeah. Yeah. X could be, yeah, that's a good option. X could be that. Anyone else has any other choices? If x is 2, then what is h? If x is 2, what is h? 8,000, right? 8,000? Because x squared would be 4. You're dividing by 4, you get h to be 8,000, right? Can you pick x to be equal to the total depth of students in US, like over 1 trillion? Was that? Yeah, if I pick x to be that, what would be h? So basically I can make the box really wide, okay? And then the height would be very tiny, right? Or I have the option to make the base of the box to be really tiny. So I can pick x to be very small, like 0.5 or something, very tiny. And then I'm going to have the height of the box really. It's a really long box, then, right? Am I making sense? So I can have a really tall box, small base, or I can have a really big base. It'll be very short box. So there are, how many options are there? How many possible pairs of values of x and h can I pick? Infinitely many choices. So given the manufacturer has infinitely many choices for x and h, right? Does any of those choices make sense? I mean, should the manufacturer go with any of those choices? The answer is no, they are not that dumb. They don't want to make the surface area too big, otherwise the cost will be too high, right? So think about a manufacturer who's smart enough to make that choice. Another manufacturer who doesn't know how to make that choice. Okay? Who's going to be more competitive? The other one. So the question is then, we are trying to minimize the surface area given that constraint equation. So let's write that down. We are trying to minimize, and these are really real world problems because, of course, this is a more simplified one, but if you go to any big manufacturing company in US like EE or 3M or many others, they hire engineers, scientists, not to just make machines or anything, but also hire people to think about these problems. They want to minimize their costs. They want their manufacturing process to be very effective, right? If you have a manufacturing process where more than 10% of the finished products are defective, right? Well, you're losing money, okay? So you want to minimize the defects, right? The amount of defects that you are creating. So in any way, let's minimize the surface area. And the surface area is what? Can someone tell me what's the surface area? What is the surface area? Remember, the top is open. So what's the total surface area? What's the area of the base? The area of the base would be x squared, okay? What's the area of the other four sides? What's the area of each of the other sides? X times h, right? Because if you look at this side here, x and height is h. If you look at the right side, the height is h. If you look at the left side here, height is h, right? So the area of each of the other four sides is x times h, right? So what's the total? 4xh, yes, very good. So that's my surface area function, and I'm trying to minimize that subject to the volume being, volume is x squared times h, the volume being 32 32,000. Okay, note that from here I can solve for h, and I get 32,000 over x squared. So you can pick x to be whatever you want, but pick h according to this equation. The volume would be 32,000. Right? So pick x to be 0.1, 0.2, 10, 20, 1 million, 3 trillions, whatever you like, but then you have to pick h according to this equation so that the volume is still 32,000 cc. Is everybody okay? Now, again, we cannot deal with a function of two variables. My quantity surface area depends on x, depends on h. I cannot deal with two variables, so let's reduce to one variable, and we could do that. So we are trying to then express s as x squared plus, remember this was what? 4x times h, and I can replace h by 32,000 over x squared. And then I'm getting what? This would be x squared plus, what is that? 4 times 32,000 is what? 128,000, isn't it? Divided by what? Divided by x, yep. Okay, so that's my surface area function. I'm almost done, except that now I know I have to find the minimum value of this surface area function, but I need to know on what domain. I need to know on what domain, right? Let's think about it then. X is not negative because if x is, we are talking about length of a box, so it shouldn't be negative. I can take x to be non-negative. Can x be 0? No, if x is 0, the volume would be 0, so that's not a possibility either. Because remember, the volume has to be 32,000. Now the question is, can x be any positive number? And the answer is yes, like we said. If x is whatever, you can pick h according to that constraint equation, and the volume will be 32,000. So now once I get here, once I have arrived here, I am done. I am done in the sense that all I have to do is same old calculus problems from 3.3. So what do? Well, we try to find the minimum value of this, and the thing that we have to do is find the derivative first. So what's the derivative? The derivative would be 2x, and then what's the derivative of 128,000 over x? Negative what? Does everyone agree with that? You see that? 128, you don't have to apply the quotient rule, which you can, but notice that what you have there is 128,000 multiplied with x to the negative 1, right? This is what you have here, right? So what's the derivative by the power rule? Negative 128,000 times x to the negative 2, and x to the negative 2 is the same as 1 over x squared. So that's how she's getting that. Okay, so then I have to solve s prime of x equals to 0 or s prime of x does not exist to find the critical points. Once again, this is when x is 0, but I don't care about x equals to 0. It's not in my domain. And then I need to know where the derivative is 0. And that happens when 2x minus 128,000 over x squared is equal to 0. And from this I have to solve for what? Solve for x, right? So this means I have 2x equals to 128,000 over x squared, and then I have 2x cubed equals to 128,000. X cubed is what? 64,000 if I divide by 2. Is that okay? And then what is x? What is x?
40.
Very good, 40. And so I see that I have only one critical point, right? But again, I have to justify still that the minimum value occurs at 40. So how do I justify that the minimum value occurs at 40? Well, I draw the domain on the real number line. The domain is from 0 to infinity. At 0, I have a hole because it's not in the domain. And then at 40, I have a critical point. And I need to know the sign of the derivative on the left and right side of 40. Look at the derivative function. Remember, the derivative function is exactly this guy. When x is less than 40, what is the sign of that? When x is less than 40, for example, plug in 1 for x, what do you get? Positive or negative? What's that? When x is 1, what's the sign of this guy? What's that? Negative, right? You have 2 times 1 minus 128,000 divided by 1, right? So I get a negative here. And then if you pick x to be bigger than 40, x squared would be bigger than 16,000, right? No, sorry, 1600. And then when you divide 128,000 by that, you get something less than 80. And the first term is 80, right? You realize that? Well, you can just plug in something like 50, okay? And see that, so if you plug in 50, you get 100 here. If you plug in 50 here, for example, you get what? 2,500. And then when you divide, you'll see that you get something less than 100. So what's going on here then? Well, it's positive here. Is everybody okay with that? And another way of seeing this is that, remember, when you pick x to be 40, what is x cubed? X cubed is this guy, right? So what is x squared? That would be 1600. So if the denominator is bigger than 1600, then you see that this is less than this. Okay. In any case, just plug in some number, you realize that. And so what can I say about s? Decreasing, increasing, justifying the fact that s of 40 is the minimum surface area. And when x is 40, then what can I say about y or h? H would be? H is, remember, 32,000 divided by x squared, right? So what is that? 20, yes. So what are the dimensions of the box? My answer would be, I need to make a box which is 40 by 20, right? And that's going to minimize my surface area. Everybody's okay with that? All right. Okay, let's do one more example. This is going to be, I think it's problem 7 from your homework. Find the dimensions. Find the dimensions of a rectangle with parameter perimeter 100 meter, whose area whose area is as large as possible. Is everybody clear on what the question is asking for? Again, draw a diagram if you can in order to understand the problem. Let's say the dimensions of that rectangle are given by x and y. We are trying to find the values of x and y so that the area is as large as possible. So what am I trying to maximize? Maximize A, which is what? X times y, and subject to what constraint? What's that? The constraint is that the parameter is equal to what? The total parameter of the rectangle is what? What's that? Yeah, and in terms of x and y, what is that? Just x plus y, or 2x plus 2y, right? So 2 times x plus y, right? So 2 times x plus y is 100. So what does that mean? It means that x plus y is what? 50, and I can say that y is 50 minus x. Okay, so now we are trying to maximize the area which is x times y, but instead of y I'm going to write 50 minus x. So that's the function that we are trying to maximize, which is 50x minus x squared. But I have to know what's the domain. On what domain was that? Okay, x has to be non-negative. Okay, and so I know that x has to be non-negative. So 0 is less than or equal to x. But can x be anything at all? Can x be anything at all? If x is larger than, think about it. If x is larger than, what's the maximum? How large can you pick x to be? Your parameter has to be what? Your parameter has to be 100. So can you pick x to be whatever positive you want? What's the maximum value of x you can pick? 50, because if x is bigger than 50, the parameter has to be what? Bigger than 100. Right? If x is 50, what is y? Y has to be 0. In that case, the area would be what? 0. Right? So the possibilities are that x has to be between 0 and 50, right? Those are the possible values of x. X couldn't be bigger than 50, yeah. Well, if it is equal to 50, then y value would be 0, then the area would be 0, which is fine. We are trying to maximize the area, so we are allowing 0 area. Am I making sense? So this is the domain that I'm picking, and then my point is, taking x to be 0 does not violate my constraint equation. Remember, my constraint equation says the parameter is equal to 100. That constraint is not violated when I take x to be 0. Because when I take x to be 0, I am simply picking y to be 50. And then the constraint equation is still true. Okay? So, what is a prime? A prime would be 50 minus 2x. And then I have to solve a prime equals to 0, or a prime does not exist, and no solutions here. And then 50 minus 2x would be 0. That tells you x is what? That tells you x is 25. Now, if x is 25, okay. So this is I get only one critical point, right? On a closed bounded interval, how can I find the maximum value? I make a table, right? X and A. When x is 0, what is the area? When x is the right-hand point of the interval, the area is 0 as well. And when x is 25, whatever the area is, you can get it here, and that's the maximum, right? For sure. What is the corresponding y value? 50 minus 25, which is 25 as well. So what does it tell you? It tells you if you are given a perimeter, the way you can make the area, enclosed area, as large as possible is if you make the room square. That's why if you are making a room, you try to make it square, because if you make it square, you have the largest possible area enclosed. Okay.